Hi class, this is Gigi. I am going over my math lab question number 20 in the optimization problem, the one with the train. So the problem is saying that you are, here's a train track, right? There's a train track right here. Excuse my crazy drawing here, but here's a train track, right? And you are standing right here. That's you. Okay, so you are here. Okay, and then that is 1/5 mile away from the train track. Okay, and so the train, so here's the choo-choo train here, going right here. There's the train. And the train is 1/12 mile length. And it is moving this way. It's moving that way at the rate of, and it's moving this way at the rate of 13 mile per hour. Okay, so that's the train. Okay, and so the question is, as the train is moving ahead, so it's moving, the train is moving ahead. What's the slowest speed? What's the slowest speed that you can run and still be catching the train? I mean, obviously, you are not going to run here, right? You're not going to run there because the train would have probably been gone. So you're going to run towards the train. You're going to run towards the train. And so the train is moving. It's moving this way, okay? And so you are going to catch the end of the train, right? So the question is saying, well, what's the slowest speed that you can run and still catch the train? And still catching the train means you're gonna just catch the end of it. Okay, you just barely made it because you want the lowest speed. You're gonna run as slow as possible, right? So the train is moving forward. This right here is 1/12 of a mile, that length, right? 1/12 of a mile, that's the length of the train. All right, so let's put some variables in here. Let's call this x. Okay, from the point where closest to you to the end of the train. All right, so how far has the train gone since since the time that you started running until the time that you are here? Well, the train has gone x plus 1/12 miles, right? So because we're looking at from here to here, that distance is x plus 1/12 of a mile. Now, how long does it take for the train to go that far? So you say time that it takes the train to travel that distance. And of course, time is distance divided by velocity, right? So t is equal to distance divided by velocity. The distance is x plus 1/12 divided by the velocity is 13. Okay, that is the time that it's gonna take for you to run from here to there. Okay? The time that it takes for you to run from here, from where you are to the end of the train, is going to be the same time that the train is traveling that distance, which is x plus 1/12 divided by 13. Remember that. Okay, but the question is asking, what is the velocity? So we have to go and write a velocity function. Velocity is equal to, again, distance divided by time. The distance you are traveling, and as you can see, here's a right triangle. That's 1/5. That's x. So this is square root of x squared plus 1/25. 1 over 25. Right? A squared plus b squared, and then square root it. So the distance is going to be square root of x squared plus 1 over 25. Divided by the time that it takes, which is x, plus 1 over 12, all divided by 13. That simplified to be the velocity function. Oopsie, not in terms of t now, but in terms of x is, okay, so the distance is, the velocity is, divided by this, you can move the 13 up, so that would be 13 square root of x squared plus 1 over 25 divided by x plus 1 over 12. Okay, so that's the function that we want to minimize. Okay, so I think the hardest part is to understand what the question is saying, right? So we have a train going and we want to catch the end of it. The time that it takes for you to get from where you are to the end of the train is the time that the train has traveled that distance. All right. So to minimize that function, we are going to have to find the derivative. So the derivative is quotient rule will apply. So I will have x plus 1 over 12 square on the denominator. The derivative of the numerator would be 13 over 2 square root of x squared plus 1 over 25 multiplied by inside derivative, which is 2x, and then we can see that 2 is going to cancel with 2, okay? Multiplied by the denominator, which is x plus 1 over 12, minus the derivative of the denominator, which in this case would just be 1, multiplied by the numerator, and that is 13 square root of x squared plus 1 over 25. Okay, so we're going to clean that up. When we do clean that up, we will get x plus 1/12 square on the denominator. On the numerator, I have 13x over square root of x squared plus 1 over 25 minus 13 square root of x squared plus 1 over 25. It looks scary, but no worries, because in order to find the minimum, we will have to find our critical points, right? And our critical points would be when the derivative is equal to 0. So when is this derivative equal to 0? When the numerator is 0. And we don't need to worry about this denominator being 0 because it's something square. Something square is always a positive number, right? And x plus 1 over 12 squared is going to be greater than 0. All right, so we don't need to worry about it being undefined. We just need to worry about the velocity equal to 0. Not v of 0, but when is the velocity equal to 0? It equal to 0 when that numerator is equal to 0. That means I have 13x divided by square root of x squared plus 1 over 25 is equal to, that's minus, I move it to the other side, 13 square root of x squared plus 1 over 25. Now, to go ahead and solve that, we multiply both sides by the thing that we are dividing by. So that means we are multiplying both sides by square root of x squared plus 1 over 25. All right. So when we do that, we will have something that is very nice and clean. Okay, so I'm going to give myself some room. When I do that, I will get, this is going to cancel out. I will get, oh, sorry about that. There was something multiplying. I forgot the x plus 1 over 12 here. Okay, so I will have x, 13x times x plus 1 over 12 there. Okay, forgot that term right there. Oopsie. Okay, so of course this is going to cancel out when we multiply. So we'll have 13x squared plus 13 over 12x is equal to, so when you distribute that into there, you would say, hey, square will undo square root. I will have 13 multiplied by x squared plus 25, which is 13x squared plus 13 over 25. Well, good thing that these are the same. So we can subtract that from both sides. And when we subtract that from both sides, we'll have 13 over 12. X is equal to 13 over 25. To solve for x, we would say x is 13 over 25 multiplied by 12 over 13. And that is 12 over 25. Roughly 0.48 if we want a decimal. Okay, actually that is exactly 0.48. Okay, so that's the critical point, right? Okay, so if we check to the left and to the right of the critical point, we will see that it will be decreasing and then increasing. And I won't do that just for the sake of time here. If I put that on the number line, I will say this was decreasing and this is increasing. Therefore, this thing right here is going to be our minimum. Okay, so x equal to 0.48 is our minimum. But the question is asking not for the x value, but the question is how slow? What's the slowest you can run? That means we are talking about the velocity. So we would go ahead and plug in 0.48 to the velocity function. And when we do that, we will get 12. How nice. And the unit will be mile per hour. So the slowest you could run to catch the train, okay, so remember this scenario here. You're right here. You're right here, right? And you're going to have to run towards the train in that direction. You're going to have to run at a rate of 12 miles per hour. That's the slowest you could run in order to still catch the tail end of that train. When that train is going at a speed of 13 miles per hour and the train is 1/12 of a mile length. Okay, that's what the question is asking you. And that is question number 20.